Hey everyone, Professor Tang, thanks for watching. For my AI thinking project, I picked actor-critic methods because they feel like the closest thing AI has to how we actually learn in real life. By trying stuff and getting quick feedback instead of waiting until the end to find out if we messed up, the title says it all. These methods team up two parts of the brain to make smarter decisions. You see the classic reinforcement learning loop at the bottom: state, action, reward, better policy, updated policy. And by the end, you'll understand why this is powering everything from robot hands to self driving cars. All right, let's dive in. So, before we get to the cool stuff, let's make sure we're all on the same page with basic reinforcement learning. Imagine you're training your dog, or in my case, trying to teach somebody how to ride a bike, my daughter. The agent, that's you or the person, my daughter, looks around and sees the current situation. That's the state. Then you pick an action, like pedal harder, turn left. Right away, you get a feedback, a treat, or a reward if it worked, or a pain or a scraped knee, so to speak, if it didn't. And you move to a new position, and the whole goal is to collect as many good outcomes as possible over time. Traditional methods a lot of times make you wait until the whole bike ride is over to learn anything, which is slow and not as efficient as it could be. The actor critic method fixes that, and you'll see how in the next slide. All right, this is some of the cool stuff. Actor critic splits the work between two neural networks that work together like a team. The actor is the doer. It looks at the situation and decides, what should I do next? That's the policy. The critic is the judge. It watches what the actor just did and says, okay, that was pretty good, or that wasn't good, or that was kind of wobbly. And it gives a score using something called the value function. Just like I said with the kid learning how to ride a bike, the actor tries turning the handlebars left or right. Me or the parent standing right there shouts out to them, good balance, or you're leaning to the left too much, shift your weight. Then the kid doesn't have to learn the lesson by crashing in order to be trained to ride the bike. The instant feedback is why actor critic learns so much faster and smoother than older methods. So, how does this teamwork actually happen? Step by step. First, the agent sees the current state. The actor picks an action, maybe pushing a cart left or right. In the classic cart pull game, the environment gives a reward and the next state. Then the critic quickly calculates the advantage. Basically, was that move better or worse than was expected? Using that signal or that calculation, the actor updates the policy to pick better actions next time, and the critic gets better at judging, and the loop starts again. Look at the flow chart on the right here. You can see the loop happening as it does in real time. There's even the math formula at the bottom, the equation formula. You don't need to understand exactly what that means, but the key takeaway is that AI can now learn on every step of the process instead of only at the end with the actor critic method, which is huge for real world stuff where time is sensitive. This slide is kind of a visual putting together everything. On the left, you see plain reinforcement learning. The robot is wandering a maze, getting rewards, updating its policy, as we talked about. In the middle is the power couple. The actor holding up the script saying, I'll try this action, and the critic with the clipboard giving the score right away. On the right, you see the full workflow: environment, agent, environment, agent, critic feeding, and back the advantage. Actor improving the policy. The result is faster, more stable learning, and better policies because the two parts keep each other in check. It's like having a coach who doesn't just watch the game, but actually tells you how to play and gives you advice during and between every play. That synergy is what makes Actor Critic so powerful in practice. And finally, why should we care? how does it affect us in the real world, or how does it work in the real world? In robotics, teams at both Berkeley and Google used a popular version of the soft Actor Critic to teach real robot hands to turn valves and stack blocks in just a few hours, not days, weeks. And also in games, OpenAI's bots that beat pro Dota 2 players were built on Actor Critic foundations. Closer to home, self-driving cars use the same idea. The actor decides, should I merge now? While the critic instantly checked, is that safe, or are we going to cut somebody off or crash? The big benefits are stability, handling continuous actions like steering, walking, etc. The main challenges of Actor Method is designing good rewards and needing, a lot of computing power. But in my opinion, the payoff is huge and absolutely worth it. So Actor Critic is already helping build safer roads, more helpful robots, more powerful technology, and etc. Thank you for watching, everybody.